Hi everyone, welcome back. So in the last part of this video, we looked at the reduced row echelon form and the row echelon form. And for each of those, we found that there were properties that had to be satisfied in order for a matrix to be in one of those two forms. So for example, with the row echelon form, we found that there were three properties. And for the reduced row echelon form, it had to satisfy the three properties from the REF, plus there were two additional ones. And we also looked at some examples, and as you can see, we have a couple more examples here. So the one on the left is an REF, and the one on the right is an RREF. And you can consult the properties that we discussed last time and compare each of those matrices to those properties to see why each of these matrices is classified in each form. So the point of understanding the two types of the row echelon forms is because our goal is because we're using matrices to solve a system of linear equations, our ultimate goal is to get the matrix into reduced row echelon form. And the reason is because this allows us to read off the solutions to the system. But how do we do that? That is, how can we take a matrix and convert it into row echelon form or reduced row echelon form? So this can be done using what's called the Gaussian algorithm. So let me write that, the Gaussian algorithm. And the basic idea of the Gaussian algorithm is that it's going to apply what we call elementary row operations through a series of steps to bring the matrix into REF or RREF. So first we have to understand the idea of elementary row operations. And as you can see here on the board, I've written the three types of elementary row operations. So let's look at each of these. So the first one we have is that we can add a multiple of one row of a matrix to another row of the matrix. So in notation, the way we would write this is we would say, let's say we have a row I and a row j, and we wanted to add some multiple of j, row j to row I. And c here is a non-zero constant. So what this is saying is that we're going to take our row j and multiply that by some constant, some non-zero constant. Then we're going to take that result and we're going to add it to our other row. And then we're going to put it back into that row. So to see an example in action, let's suppose we had this matrix. Let's say 1, 2, 3, 0, 1, 2, -3, -6, 1. So let's say I wanted to add 3 times row 1 to row 3. So how I would write this is I would say, okay, row 3 plus 3 times R1, and that's going to go to R3. Now, it's important to note that when we do this calculation of 3 times row 1, or a constant times some row, we're not actually going to be changing that row. So, in other words, our row 1 is going to remain unchanged. What we're going to do is we're just going to think about if we could write it off to the side. Like, think about what would happen if we multiplied 3 times row 1. So that would be, I'm going to write that in green here. So it would be 3, 6, 9. And then with that result, we're going to add that to row 3. So in this case, our row 3 was the -3, -6, 1. So what we do is we add 3 to -3, and we're going to put that back into row 3. So that's just going to give us 0. Then we add 6 to -6, which will again just be 0, and we put that back into row 3. And then 9 plus 1, which is 10, and that will form the last entry of row 3. And so we can then just remove that piece, and then that's the result of doing adding a multiple of one row to another row. And that's an example of the first type of row operation. So the next one is we can multiply a row by a non-zero constant. So the way that looks in notation is we have a non-zero constant c, and we multiply that by a row, say row I, and then we put that result back into that row. So notice in this case we're actually going to be changing row I. So like to look at it as an example, let's go back to this one that we were working with earlier. Let's say I wanted to get a 1 in this position here. So what I can do is I can multiply that row 3 by 1/10 and then just replace it. So then how that will look is that our other two rows will be the same. And then in the bottom, we're just going to have 0, 0, 1. And this, again, this is an example of multiplying a row by a non-zero constant. And finally, for the last one, we can swap two rows of a matrix. So the way that looks in notation is we have a two-sided arrow. So what this means is that we're going to take row I and we're going to switch places with row J. So basically, like to use an actual example, let's say we were swapping row 1 and row 2 in a matrix. What this is going to do is we're going to take row 1 and we're going to put it in row 2. And then our row 2 is going to go to row 1. So to look at an actual matrix example of that, let's say that we have this matrix 0, 1, 1, 0, and we swap row 1 and row 2. So we're going to put row 2 in row 1, and we're going to put row 1 in row 2. So our row 2 here is going to become our row 1 in the new result. And our row 1 up here is going to become row 2 in the second result. And this is what we eventually will end up with as a result of that row swap. So these operations might seem kind of familiar because they might seem rather similar to steps you used, say, in your algebra class for manipulating equations in a system to solve for x and y. And if you made that association, you'd be right. Because remember that we can use a matrix as a representation for a system of linear equations. So, like, let's say, for example, we had this system. Let's say we had x1 minus 3x3 is equal to 8. 2x1 plus 2x2 plus 9x3 is equal to 7. And x2 plus 5x3 is equal to -2. So we could use our algebra skills to do some operations on the equations, like, say, adding or subtracting equations, multiplying an equation by a non-zero constant, or maybe swapping positions of equations. And that's just like the row operations that we would do on a matrix. So now that we're in linear algebra, we can apply our linear algebra skills from what we've just learned here with the elementary row operations. And we can solve this system by writing it as a matrix and applying the elementary row operations. So in the next video, what we're going to do is we're going to go through putting this system into a matrix, and then we're going to learn the Gaussian algorithm on how to systematically row reduce the matrix to find the solutions to the system.